So in terms of our acids and bases, right, from the last lesson, we discussed the definitions of acids and bases, and then we looked at the fact that bases dissociate in water, whereas acids, they ionize in water. So which means when you represent the reaction of an acid, for example hydrochloric acid, when you represent its reaction with water, you say that it forms H3O plus in aqueous solution plus Cl minus, which is also in aqueous solution. So what it means is that if you have like a powder HCl, so let's say it's a powder, and then you have water. So when they react, right, or rather that acid is gonna dissolve in water, but when it is dissolving in water, it actually forms ions, and the ions that we will have is this one and the Cl minus, right? Now this ion, remember that it's called the hydronium ion. The hydronium ion, and the Cl minus is also just an ion. So this what makes HCl an acid according to Laurie Bronsted and Arrhenius theory, because Arrhenius says an acid is anything that produces hydrogen ions or hydronium ions when it dissolves in water, which we can see from this reaction. Laurie Bronsted says an acid is a proton donor, and indeed this HCl, it did donate H, which is a proton. We're talking about H plus ion, right? H plus ion is called a proton. So it donated this H to water, such that now we had H3O plus, because we had H2O, but now we have H3O, which tells us that where did the other H come from? It came from HCl. So which means HCl donated, and by it donating, that qualifies it to be called an acid. So an acid, anything that donates an H proton or anything that produces H3O plus in water. That's how we define it. Whereas for a base, for example sodium hydroxide, these bases, when they dissolve in water, they dissociate. So when it dissociates, it's just gonna become Na plus and OH minus. So what happens there is that bases is like they just split. So it just splits into two. Okay, it splits into two, and as it splits, it forms OH minus. So because it forms OH minus, we call it a base, because according to Arrhenius, anything that produces a hydroxide ion, by the way, this is called a hydroxide ion, so anything that produces a hydroxide ion, we call it a base. And at the same time, Laurie Bronsted says a base is something that receives a proton, where it's not very much visible here that there is anyone that received a proton, because we didn't say plus H2O, but then you need to just know that it receives a proton. To see that an acid receives a proton, it's much better to see that through reaction with an acid. So in those acid base reactions, that's where it's easy to see that an acid donates H plus and then a base receives the H plus. But we'll do that when we do the reactions. So in our last lesson, we also looked at what we call a conjugate acid and a conjugate base. Then we looked at monoprotic acids, diprotic acids, right? And then I also mentioned that we have triprotic acid. So this is the amount of H atoms, H protons that they can donate. So for today, why is it important to know how to write these reactions? Well, if you know how to write those reactions, then you can be able to calculate what we call the pH of a solution. So that is the whole main idea of knowing how to write the reactions, is so that you can be able to calculate the pH of a solution. For example, let's start with the first question. Um, well, let me give you the formula to calculate pH. Or rather, what is pH? What is a pH scale? Can anyone describe to us what is a pH scale? You must have done this in grade 9. pH scale. What is that? Any idea, Mr. Kevin? It's got 0, 7, and 14. Okay, let's put that 0, 7, and 14. Ah, great. So it means you have some sort of idea that a pH scale tells us that between 0 and 7, these are acids, between 0 and 7. And then between 7 and 14, these are bases. But then at 7 straight away, then we say that substance will be neutral. Example of a neutral substance is what? It's water. Well, is water really neutral? No, it's not. But then we usually just take it as neutral. We're talking about pure water. Yeah? Pure water is neutral, whereby it's not acidic, at the same time it's not basic. Bases, right? They are called basic substances. Sometimes they are called alkaline substances, right? So it's just different ways to describe bases. Now, acids are going to have a pH between 0 and 7. Now, the more you move to the left, the stronger is the acid. Tell me something. Let's say I tell you that HCl has a pH of 1,6. Remember, pH doesn't have units. And then let's say I say to you nitric acid has a pH of 3,9. Miss Katleho, which one would be a stronger acid there? HNO3. Alright, so Miss Katleho says, sorry. Oh, it will be HCl. Why HCl? That is correct, ma'am. The lower is the pH value, the stronger is the acid. Is that okay? Great. So we must know that the lower the pH value, the stronger is the acid. So we have some strong acids and we have weak acids, right? But we'll talk a bit more about that in a few. Now, Miss Uri, let's say that you have a base, right? Sodium hydroxide with a pH of 13,4, and then you have sodium bicarbonate, which you use in your baking, is it baking powder or soda, something like that. And then you have it has a pH of around 10,7. So which one would be a stronger base, Miss Uri? You'd go with 13,4 to say it's a stronger base, and that is correct, ma'am. So indeed, NaOH will be stronger, whereas NaHCO3, sodium bicarbonate, is it sodium hydrogen carbonate, it's going to be weaker. So the thing is, the more you move to the right, the stronger is the base. Okay, so that is how a pH scale works. So different substances fall under different levels of the pH scale. You have some common everyday substances that we can have. Now let me see if I can have a nice picture on that we can look at. Yeah, the network is a bit somehow. Let's see. Okay, I think I have one here. So okay, I mean, it's also good that we're going to have to know which ones are strong and which ones are not, but I wanted this copy image. Hopefully it will paste. 1 2. Where is it? Nice. Thank you so much, Stanford Advanced Materials, as keys for stealing your picture, but it's just for illustration purposes. So as you can see there, can you see the everyday items that we have and where they fall under? Look at the battery there. Look at the battery. pH 0. That tells you, what does that say about a battery? That tells you that a battery is very acidic, isn't it? That tells us that a battery is very acidic. So that is one thing we might need to make sure that we are able to observe there, right? Yes, you can ask. How is coffee an acid? That is a very good question. I mean, taste coffee. How does it taste? Doesn't it taste a bit bitter? Your acids are bitter, right? So that's what happens there. And that's what we can observe in things such as coffee. Yeah. And look at a lemon there, right? Quite acidic too. By the way, those things that are acidic can be used for electricity. For example, you can make a battery out of lemon because the acid actually, since acids ionize, they form ions. These ions can move and act as carriers for electric charge, or rather carriers for electrons. But then that is a topic for another day. But I just wanted you to see that things like your tomato, slightly acidic, right? Milk slightly neutral, blood slightly alkaline or basic. So these are your common things that you come across. So quite helpful to remember that. Now that we know the pH scale and some of the substances that fall under there, and that we know what is pH now. Who can tell me what does pH stand for? Is there anyone who has an idea what pH stands for? I'll buy you a sweet if you can tell me what does pH stand for. Anyone? Yeah. It's gonna be difficult to know that one, eh? But then it's fine. Yeah, that's your homework there. Go and check out what pH stands for. Ne? Quite a beautiful is it acronym or abbreviation? Yeah. So how do we calculate pH of a solution? Here's the thing. We said we have acids, we have bases, right? So if I have a solution, meaning an acid dissolved in a water or a base dissolved in water. So know that if I say to you solution, I'm talking about either an acid in water or I'm talking about a base dissolved in water. So I would want to know what is the pH of that solution, or what is the pH of that solution. Now we have a formula to calculate pH, which is this: negative log concentration of H3O plus. Right. So let's understand the following. It's negative log. Now here, those brackets, in chemistry, the square brackets, they mean concentration of. Okay? So whenever you see those square brackets, I'd like you to think of that. Concentration of. And then it's H3O plus. Yes, not H2O, because H2O, remember, that would be your water, ne? So it's going to be H3O plus. Now that we know the formula, and we know that these brackets means concentration of, in terms of the formula to get concentration of H3O plus, you use the formula C is equals to N over V. So you calculate the concentration of your H3O plus. Okay, so what you put here must be the concentration of H3O plus. Now sometimes someone might ask, how do I get the concentration of H3O plus? And that's a very, very good question that you will have to make sure that you know how to do. So let's go through some examples, or rather some problems, and see how we can calculate the pH of a solution. Now our first question says 2 grams of hydrochloric acid dissolves in 500 ml of water. Calculate the pH of the solution. Please write this down, because we might need this as our reference. Right, were you able to jot it down? So you can indicate to me as soon as you are done there. All good? Right. So, what is the first thing that you do as soon as you get a question like that? Ne? We want to, first of all, um, get the reaction that is going to. Okay. So, here's the thing. HCl, you know that's your hydrochloric acid. So what they are saying is that you have a powder. You take HCl, it could be a powder, it could be lumps, right? But it's in solid form. So you take it and then it dissolves in water. Now remember, water is a liquid, right? And then the reaction, what's going to happen? Remember that H will donate, HCl will donate that H, and then you're gonna have H3O plus. Don't forget to indicate that it's in aqueous solution. I mean, now we understand what does aqueous solution mean, right? So you need to always make sure that you indicate it. Then from there, you say, now that it donated H, you're going to have Cl minus. This is the reaction. So what do we then do? Remember that we cannot just simply calculate the concentration of ACE. I mean, we have the mass. This is the mass, which is M, and then we have the volume, right? So since we have mass and volume, we can actually calculate the concentration of HCl. So then you would say C is equals to N over V, right? That would be, but remember, this is concentration of HCl. So why? Remember that you are given information on HCl, so it's concentration. Since you are given mass, you might want to use the other formula, which is mass, molar mass, and then you multiply that by the volume. Okay, so what is the mass that is given there? So the mass is going to be 2 grams. What is the molar mass? Remember, I think for chlorine the mass is 35.5, right? And then the other one you have you have 1 for hydrogen. So when you add them, it should be 36.5. That's the molar mass, guys. Remember, you get it from the periodic table, ne? So I think it should be 36.5. And then what is the volume? You are given in milliliters, sorry. So one thing about milliliters is that when you convert it to when you convert milliliter to decimeter cubed, because we work in decimeter cubed, you just need to remember the following. 1 milliliter is the same as 1 centimeter cubed. And to change from centimeter cubed to decimeter cubed, please remember that we divide by a what? 1,000. So being given milliliter is the same as being given centimeter cubed. So therefore you just need to divide that number by 1,000. I repeat again, if you are given milliliter, ne, that is the same as being given centimeter cubed. Okay, so if you are given that, you need to make sure that you convert it to your decimeter cubed and you divide by 1,000. However, let's say you're given in liters, ne? Let's say I give you 2 liter or 3 liter. Please know that liters are the same as decimeter cubed, ne? Please know that, because in most cases that's what they like to do, and then people are confused. Please know this. Know that 1 liter is the same as saying 1 decimeter cubed. Okay, did we get that? So Mr. Kevin, what would be 20 liters in decimeter cubed? Right, it's going to be 20 decimeter cubed, right? So yeah, that's what we need to know, because when you even look at the formula for concentration, you must go and check your list of definitions. When we describe what we call a what you call when we describe a concentration, or rather definition of concentration, it says that the number of moles per liter of solution, right? And why does it say per liter? This is because decimeter cubed is the same as a liter, right? So hope that we got that. And then now here, because we have 500 milliliter, you divide by 1,000, then you'll be able to convert that to liters, which is converting it to decimeter cubed. And then I believe it should be 0.5. I think it should be 0.5. So can you get for me the concentration? What do you get? Right? Anyone who got the answer there? The concentration. Remember that um, the not we the other way is to get number of moles, then you substitute them over volume, but we're not gonna do that because we're just gonna use the other formula for concentration, which is m over m, which is still number of moles. This is number of moles, ne, over the volume. So I just want perhaps the final answer for this when you put it in your calculator. What does it give you? 0.1096. Okay, 0.0196. Remember the units, guys, ne? Mole per decimeter cubed. Yeah? 0.1096. Okay, great. Yeah, and then your definitions there. So sometimes, but this is like maybe, I think it's not really necessary, but know that these units sometimes they can write them as mole per liter, ne? But most probably this is used in varsity. But yeah, you just have to know it. Decimeter cubed or is the same as your liter. So now that we have the concentration of HCl, remember this is not what we want to get pH, because the formula for pH says pH is equals to negative log of the concentration of H3O plus. So what does this tell us? We need the concentration of H3O plus. For now, we only got the concentration of HCl. So how do we get for H3O plus? It's quite simple. You just look at the ratio. Since the ratio is 1:1, I mean everything is balanced there. Look, there is 3 hydrogens, there is 2 plus 1, which is 3. There's 1 oxygen, there's also 1 oxygen, 1 Cl, there's also 1 Cl. So that tells you that the reaction is balanced. So we then look at the ratio. The ratio is 1:1. If the ratio is 1:1, that tells you that the concentration of HCl, ne? Let me write it here. Concentration of your HCl will be the same as the concentration of the H3O plus, ne? Because the ratio is the same. So therefore, the concentration of your H3O plus is also going to be 0.1096 mole per decimeter cubed. Then from there, that's when you can substitute it into your pH and say negative log 0.1096. When you substitute this number, you no longer put square brackets, but you put round brackets. So what do you get as the answer? Yeah, 0.96, ne? All right. Let's write 0.96. Are you sure it's this one? Is that what you all guys get? You also got the same. Okay, great, great. Right, so let me just write that. So therefore, what does it tell you about this? Because that is the pH name. So that's your pH. So what does it tell you about the pH of ACl there in that solution? It tells you that this is quite a strong acid in that way, because of that the number is close to 0. I can remember we looked at the pH scale. So 0.96, when you look at it, falls between 0 and 1. So that tells you that in that way it's a very strong acid there, or that it's, yeah, very strong. So that's how you calculate your pH. All you need to do is to get the H3O plus, the concentration of H3O plus. So in any scenario, for you to be able to get the concentration of H3O plus, you need the reaction. If you don't know how to write this reaction, then it's chai. It's what they in the street. It's chai. So you need to know all of them. Now, we can go on and maybe try to do more similar questions on that. Let me give you this one. Yeah. Determine determine the pH of a 3 decimeter cubed solution with 2 moles of nitric acid. Yeah. Determine the pH of a 3 decimeter cube solution with 2 moles of nitric acid. What do you get? Or rather, how do we do this one? Is anyone with an idea of the first step? The first step we should employ. Miss Ori, you get a question like this. What would be the first thing that you do? You write the equation, right? Okay. Do you still remember the formula for the equation for nitric acid? What do we write? The formula for nitric acid. HNO3. Okay, that is great. let's just say in solid form, and then reacts with water. Then what are we going to form as our products, Miss Owen? H3O plus. Mm-hmm. The NO. Okay. Remember H was donated. Do you agree that H is gone here? So what would be left? It would be right, NO3. Now we put a minus because when something loses a proton, it becomes more negative. But when something gains a proton, it becomes more positive. I repeat, yes. Why? Because remember, we said a proton is positively charged, electron is negative. So this guy, since it's going to donate a proton, that means there is more negative than positive. So hence we say minus to show that it's going to become more negative because it lost one proton. If it lost two protons, we might put 2 minus or minus 2. Okay. Then here it tells us that it gained a proton. So now that we have this formula, the reaction, right? What would be next, Mr. Kevin? We get the concentration of the nitric acid. So let's try to do that. We already have the moles, luckily. What is this? The volume, right? So we say the moles is 2, the volume is 3. So what do we get, Mr. Kevin, as our concentration? 0,6667. Is it like this? You know the procedure said before you reach the final answer, you wanna have 4, ne? Great. So now when you look at the ratio between HNO3 and H3O plus, do you agree that the ratio is 1? Is to 1. 1 is to 1. That is great. Guys, remember when we were doing stoichiometry, when I told you about the ratios, this is exactly the same thing you do here. I mean, for now you know the moles of HNO3, that is 0,6667, and this is X. So you just solve for X, and then you get that the number of moles, or rather the concentration of H3O plus is also going to be 0,6667 mole per decimeter cubed. So that's what you want to do. Then once you have the concentration, now you can the pH as negative log the concentration of H3O plus. Then you'd substitute there 0,6667. What do we get as our pH? Zero comma 18. Yeah, they're quite small. By the way, pH doesn't have units, so that would be correct there. But as long as they're below 7, we are totally fine. So as long as they're below 7, we're totally fine. That would be the pH of that. So that's one way they can solve it. Now let's quickly move to a base, right? Because as much as we were able to calculate the pH of these acids, we also need to calculate the pH of a base. Now, here's a question which says, Um, let's start with this one. Determine the pH of a 4 decimeter cubed solution containing 3 moles of sodium hydroxide. Now, this is a base, sodium hydroxide. But when you look at this question, what would be the first thing that you do, Ms. Katlego? For sodium hydroxide? Okay, great, that's correct. So for sodium hydroxide, guys, I need you to know that we just simply write it like this. We say Na plus in aqueous solution plus OH minus in aqueous solution. This is because bases dissociate. So we said they just split. So we split into Na plus and OH minus. Now, we need to get the pH of this solution. What is our next step, Miss Ori? Of concentration of sodium hydroxide. Okay, so let's just try to do that real quick. So we would use N over V, and then we have 3 moles over 4 decimeter cubed. I believe that should give you 0.75 moles per decimeter cubed. Now, do you remember that the pH, the formula for pH? Okay, no, rather let me ask, where do we go from here, Mr. Kevin? Mm-hmm. Mm-hmm. Yes, the ratio of NaOH to OH minus is the same. I believe it's 1:1. So what are we saying? Are we saying the concentration of OH minus is going to be 0.75? Is that okay? Okay. So now that we have that, let's go to the formula for pH. Negative log the concentration of H3O plus. Yeah. So Mr. Kevin, tell me, do you think we have to substitute that 0.75? No, we can't. Check here. It's H3O plus. Here it's OH minus. Those are not the same things, right? It's the same. You get it? So, when we calculate, right, we can then say, instead of substituting this here because it's not the same thing, Then we have to use this other formula, which we call auto ionization of water, or the Kw constant. So this formula is Kw is equals to 1 times 10 to the power negative 14 is equals to the concentration of H3O plus times the concentration of OH minus. So this is the formula that we would use. So you might want to have that so that you remember, you know, how to use it. So how do we apply this formula? We only use it because we want to get the concentration of H3O plus when we have the concentration of OH minus. So how the formula works is that you will say 1 times 10 to the power minus 14. You're looking for this, you don't have it, so you're just gonna write concentration of H3O plus, and then you do have this one because you just calculated it, so you substitute it there and use round brackets because you are substituting. Then you divide both sides by 0.75. Now that shall leave you with the concentration of H3O plus, the one we are looking for. So what do we get here in our calculator? You got it? One comma 33. Like this. Is that what you also get, Mr. Kevin? Okay, so this is the concentration of H3O plus. That's the one we wanted, guys. Now that we have it, we can simply go back to our original formula now. So we then say therefore pH will be negative log, then you substitute 1,33 times 10 to the power negative 14. Guys, if we did correct things, the pH you must get, where must it lie? It must lie between 7 and 14 because this thing is a base that we're talking about. So what do you get as pH? (13.88). Is that not a base? Oh yeah, it is. Yeah. So that's how you get the pH of a base. So you want you will want the help of this formula there whenever you need to get the pH. Now there are other formulas out there that you will get maybe online and stuff, but I think I just showed you the one I trust the most. The others, there are other shortcuts like POH, what. Yeah, no. This is the one that I mostly use. Okay, so that's how we can get pH of any solution using that. Now you must understand that we have also diprotic acids, and we need to counter for them, right? So let me give you an example of one that would contain diprotic acid so that you know how to work on it, right? So let's say the question says determine the pH. Obviously some questions are phrased differently. pH of a 5 decimeter cubed solution containing 1 mole of sulfuric acid. Okay, so then you assume that H2SO4 is diprotic. You already know it. So when they say assume that is the protic, they want you to remember that here we are talking about an instance whereby sulfuric acid completely donates all of the H protons. So what will happen is that you will have sulfuric acid, ne, then it's gonna react with water, and then it's going to form H3O plus plus SO4 2 minus. So what does the 2 minus tell us? It means it lost the 2 protons. So if it's like that, now we need to then balance the reaction. So for us to balance the reaction, we have 2 4. So you have 4 hydrogens on the left, and then you have 3 hydrogens on the right. So you might want to put a 2 here so that you have 6 hydrogens. If you have 6, that's a problem, because here you said you have 4. So you might want to put a 2 here so that you have 4 plus 2, which is 6. Then the SO4 is okay. It's SO4, and here it's also SO4. So it's balanced. Then this is how you balance it. Ne. So now you will be able to get the pH of sulfuric acid. So this one, I'm gonna leave it to you guys. Please send it before you sleep. You just try to do it for me using the same procedure I showed you, right? I gave you the ratios, and then just show me the answer that you get. Just snap the answer there so that I see how you did it. Ne. Otherwise, I hope we understand how to get pH coupled with the calculations with the conjugate acid base pairs that we did and stuff. Ne? So that on its own would leave us a bit 90% done with this topic, guys. So you just need to know those calculations. Any question? Oh, okay. 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 All right. Okay. Yes, Miss Kakao. Do you get it? Okay, perfect then. So please do send it to me before you sleep so that I just check and see if we are able to get the pH there. Ne? Um, um, if you're not done copying the question down, I'll just post the screenshot in the group there. Then I'll wait to hear from you. Otherwise, thank you so much for having me today, guys. We shall have maths on Wednesday. See you then. Good night.